Hello everyone, I am Mayank Kumar. In this lecture, I am going to discuss the inverse of a matrix. So, in this, we will discuss one by one these four subtopics. The first one is condition of existence of an inverse. Second one is how can we calculate the inverse of matrix? How many different methods we have for calculation of inverse of matrix? Then we have what are the where we will study what are the properties of inverse. Earlier, as we studied the properties of adjoint, property of transpose. Similarly, we will study the properties of inverse of the matrix. Then, what are its application? After that, we will solve the problem based on the condition, calculation, and the property of it. So let's start with the condition for the inverse of matrix and H. The very first condition is that the matrix must be a square matrix. That is, inverse of a square matrix can only exist. So the first one, the matrix must be a square. Square matrix can have square matrix are only invertible. Invertible, the matrix whose inverse can be found are called as invertible matrix. The second one is the matrix must be a non-singleness, the value of determinant must not be 0. If a matrix has its determinant value is equal to 0, then it is called singular, and if determinant value not equal to 0, then it is called non-singular. So the second criteria is the matrix must be a non-singular. Then only we can find it. Third one is, let's say we have two matrices A and B, both are square and non-singular. Then in that case, we can write A is I. If two matrices A and B satisfy this condition, then we can say that A is the inverse of matrix B as well as B is the inverse of matrix A. It means both A and B are inverse of each other. We have three conditions in which we can find inverse of matrix. The first one is the matrix must be a square matrix. The second one, matrix must be a non-singular matrix. And third one, matrix must satisfy this condition. Here we can say that A and B both are commutative. Then after changing their place, the resultant value they not change. Here IN stands for identity matrix of order n. The order of n will be dependent on A and B. Whatever will be the order of A, that will be the order of n. Whatever will be the order of B, that will be the order of n. Because A and B both have same order, so we can say that either any one of them order is equal to the order. Suppose say let's say the order of matrix A is 3. Let's so in that case we can say that IN will be 1 0 and 0 1. If its order is 3, then it will be a identity matrix of order 3. 1 0 0 0 1 0 and 1 0 0. It will be the identity matrix of order. So we can also say that if A and B are inverse of each other, then we can say A can be the B because A is the inverse of B, as well as we can say that B is equal to A inverse. B is the inverse of B. So by this we can write it as replace this A as by B inverse. We can say that B inverse into B. This is equal to B inverse, and that is equal to I. Similarly, if we replace here B by A inverse, we can see that A into A inverse, this is equal to A inverse into A, this is equal to I. So we can say that here B and B inverse commute each other. Just by changing their place, the resultant value they not B inverse into B, the multiplication of B inverse into B will give you I. The multiplication of B into B inverse will also give you. So if A and B are inverse of each other, then in that they will follow these conditions. The first one is that must be a square matrix. Second one, it must be a non-singular matrix. It is that is its determinant value must not be equal to 0. And third one, it should satisfy this. Then we will go for the calculation of inverse of the matrix. So basically, we have two ways to calculate inverse of the matrix. The first one by using the property of adjoint. The first property of adjoint was as we have studied earlier, A into adjoint of A This is equal to adjoint of A into matrix A, determinant of A into I. Here also, and in the order of matrix A or anything can happen. So by taking this and this, we can say that A into adjoint of A. This is equal to determinant of A into I. By pre-multiplication of A inverse here, pre-multiplication of A inverse here as well as pre-multiplication of A inverse. We can say that A inverse into A will give you I. A inverse into A will give you I. Here it is adjoint of A. This is equal to A inverse into I will be A inverse. The same rule, the same rule possessed by I as we can see that rule by 1. Like 1 into 5 will give you 5. 1 into 10 will give you 10. Similarly here I has the same property. I into A will give you A. I in A into I will give you by multiplying any matrix with I, its value they not change. So here it will be A inverse into I will be A inverse and it will be the determinant of. Similarly, it will be adjoint of the product of these two matrices will be adjoint of. So here you can write this as A. This is adjoint of A, determinant adjoint of A upon determinant of it by taking this thing. So this is the formula for calculating inverse of the matrix. So here you can also see that determinant of A comes in the denominator. So what we have see here in the condition that determinant A must not be equal to 0. If we put determinant equal to 0, that case this thing will be not equal. So we should take care of that determinant of A must not be equal to 0. That is A must be a non-singular matrix. The second way to calculate the inverse of a matrix is by elementary transformation. We can calculate inverse of matrix by either by elementary row transformation or by elementary column transformation. So I'm just giving a brief idea of row or elementary transformation here. How we can calculate inverse of by elementary or row transformation. We can write A as I into A. Identity matrix multiplied with A will give you same matrix. The value will be not changed. So what we have to write, we have to write any matrix A. Like if you have to calculate the inverse of matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, and we will write 1, 2, 3, 4, 5, 6, 7, 8, 9 here. Here what we have to write identity matrix with the same order of this matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, and then similar. No, we do not have to write A in the matrix form. We have to just write here. What we are going to do is, as we know that I is equal to B into A. We can write that if B is the inverse of A, then in that case we can write it I is equal to B into. So our main target is to change this matrix in the form of that is apply row or column transformation here to make it I. If you make this A into I, then in that case, whatever will be the changes corresponding to this I will result into the B. If we change A into I by using elementary row or column transformation, in that case, whatever will be changed in I will result to B, and in that case, B will be the inverse of matrix A. So what we have to do is we have to apply elementary row and column transformation here the matrix A. Subsequently, we have to apply this here identity matrix. Whatever row or column transformation we will apply here, the same we have to apply. The main target is to make it identity matrix. As soon as we will get it this as identity matrix, in that case, whatever will be the value of this matrix will be the inverse of matrix. So our main target will be convert this matrix into an identity matrix. What are the methods and how we can do? We will discuss it later. But this is the major thing which we have to do in elementary transformation. That we have to convert this A into I, and correspondingly, whatever will be the value of this B matrix will be the inverse of matrix. One more thing we can see here is In algebra, we have seen that x raised to power minus 1 is can be written as 1 by x raised to power minus 1 can be written as 1 by x. Here we do not write a inverse equal to 1 by a. In algebra, we have written x raised to power minus 1 equal to 1 by a, but in matrix, we do not write a inverse equal to 1 by a. Because in matrix, arithmetic, we have seen that addition of matrix is defined, subtraction of matrix is defined, multiplication of matrix is defined in certain condition, and division of matrix is not defined. In matrix, division of matrix is not valid. We do not divide any matrix by another matrix or any scalar. So this is not. So while calculating, you should keep in this thing that if A inverse cannot be written as 1 upon A inverse cannot be written as 1 upon because division of matrix is not allowed. So later we will discuss this thing. Till now, okay.